Hi everyone, welcome to my channel, Math is Fun channel. Again, this channel is an educational channel to help you understand your lessons in mathematics. And this channel is intended to those who are doing the online classes out there to help them realize and develop their skills and performance in mathematics, especially their lessons in math right now. So please not forget to subscribe my channel and share this channel to the friends that you have out there so that you can help them develop also their skills in mathematics. So are you ready for our video discussion for this session? I know you are all ready, so let's get started. So I'm going to share you the screen about what we are going to talk about today. So as you can see, our topic in this video discussion is all about, sorry, okay, geometric design. So we all know that this is something, or when you heard the word geometric designs, the first thing that will come in to your mind will be like related to designs or related to arts rather. So you can relate geometry in arts and sciences perhaps. So now let's be guided with our learning outcomes for this video discussion. So at the end of this chapter, you must be able to first apply geometric concepts, especially isometries, in describing and creating designs. Second, we are going or you are expected to appreciate the contribution of geometric designs to the enrichment of the Filipino culture and arts using concepts in geometry. So in this chapter or in this topic, geometric designs, as I have said a while ago, we are going to relate this one to culture and arts, the concept of culture and arts in the Philippines. Okay, relating geometry to that field or area of our life in culture and art. So are you ready? Yes, you are ready to proceed. So as you can see there, for the geometric concepts as we had learned in our previous lessons or during our elementary and high school days, we have this concept of geometry. Geometry can help enhance one's artistic prowess as well as enrich one's own culture. So it's more than the definition that we had learned before that geometry is something related or the study of figures and shapes. Because aside from that simple definition of geometry, we are also focused or it can help us rather enhance. Okay, I will highlight the word enhance. Enhance one's artistic prowess as well as to enrich one's own culture because arts or culture or arts can be related to culture and culture also uses figures and shapes which borrowed from the concept of geometry. So that's according to Rachel Bernstein and Eunice Lee 2011. They defined geometry, or they had a concept of geometry or trying to relate it as geometry is everywhere. So that's according to Rachel Bernstein and Eunice Lee. Do you agree that geometry is everywhere? Yes, we can say that because if you try to look at your surroundings, even yourself and your life, you can see figures and patterns in the world or in your surroundings, and that uses geometry or concept of geometry. So let's try to elaborate or explore what they said. According to Bernstein and Eunice Lee, we can train ourselves to find the geometry in everyday objects in works of art. Do you agree? Yes, art uses different figures and patterns which are related to geometry. We use line, shape, form, pattern, symmetry, scale, and proportion are the building blocks of both art and math. So in short, this is what we talked about last time about the relationship of math to arts in the field of arts and culture. So, with that, geometry offers the most obvious connection between the two disciplines, arts and math. Both art and math involves drawing and they use shapes and forms as well as an understanding of spatial concepts, two and three dimensional measurement and estimation and pattern. So in short, both geometry and art uses these um, things like shapes, measurements, estimations, and patterns. So they are really related to each other. So many of these concepts are evident and very obvious in the field of artwork composition. How the artist uses the elements of art and applies the principles of design. So that this is where we can say, we can see rather, the use of geometry in arts and designs. So problem solving skills such as visualization and spatial reasoning are very important also for artists, especially for the professionals in math and in science and technology. By taking an interdisciplinary approach to art and geometry, students can identify and apply authentic connection between the two subjects and understand the concepts that transcend the individual disciplines. So in short, the point in here is when we try to think of geometry, its concept, it's all about measurement, figures, shapes, patterns, and designs, which is a focus in the discipline of mathematics, or what I mean in mathematics, which can be related to other discipline, which is the arts. So this is the concept in here. We are trying to relate geometry in the field of culture and arts, which both of them will be are related to giving designs. Correct? So that is the point in here. So I hope that you can follow. You can think or you can imagine a lot of things where geometry can be applied in arts and culture and arts. Okay? So you can do that one. You can explore rather. So now let's talk about some of the basic concepts or undefined terms in geometry. What I mean is something related or terms related to this geometric concepts. We have the line. We mentioned a while ago the line. We all know that line varies in width, length, curvature, color, or direction. And I know you can illustrate and you can imagine how does line look like. Okay? So another thing also is the shape. Shapes or plane figures are two-dimensional figures in which all points lie in the same plane. Shapes can be open or closed, free form or geometric form. Okay, so I hope you will be able to distinguish the definition of these two terms that I mentioned. There's still a lot of terms that we have to remember. Another is the form. A form or a space is a solid figure or are solid figures which are three-dimensional. When we say three-dimensional, that means it has height, width, and depth, enclosed volume, and help us to understand the physical space. So that is the meaning of a form or a space. It is three-dimensional. Again, what do you mean by three-dimensional? I will highlight so that you can follow. It has height, width, and depth. Depth, rather, sorry. For example, a triangle, which is a two-dimensional, is a shape. So a triangle has two-dimensional because triangle has only how many dimensions? Two. We have the height and then the base. Therefore, it is not a form, but it is a shape. But when we say pyramid, pyramid rather, it is three-dimensional. Why? Because it has height, width, and depth. Same with the cubes, spheres, cones, and cylinders. These are examples of forms. So take down note of that. Forms and space are just the same. Okay, do not be confused about it. They can be literally three-dimensional, or they can have the illusion of three-dimensional. So I hope you can follow. Another thing is the patterns and repetition. Familiar with it? So when we say repetition, it is the recurrence of elements of art at regular intervals, repetition of figures. So that's how we defined it in our previous video discussions about pattern. So when line shapes and forms repeat in a predictable combination, predictable meaning to say it's obviously that it will repeat the same size, shape, or thing. So that is considered as repetition. So they form a pattern. Okay? So the pattern of this quilt is a tessellation. Once a shape will repeat, same size, same shape, it is called tessellation. I will just highlight a collection of shapes that fit together to cover a surface without overlapping or leaving gaps. So a tessellation has already been discussed last time, about the different types of patterns, or yeah, that in our previous video discussion. So I hope you can follow and you could still remember about what's the meaning of a tessellation. So this is pattern and repetition. So both of them are they are related. They are dependent to each other. Repetition, if there is a repetition, there is a pattern. If there is a pattern, there is a repetition. So I hope you can follow and it's very clear to you now. Now let's proceed. Balance. I know that that you have an idea rather about balance because you encountered that one in your day-to-day life. So when we say balance in here in our geometric concepts, balance is the arrangement of elements. Again, I will highlight the word arrangement. So balance is the arrangement of elements to create a sense of equilibrium and harmony. So balance will help us create an equilibrium and harmony. So there are three types of balance that we need to know. We have this, I know you encountered this one before, symmetry. Symmetry is a balance in which the shapes and patterns are identical on either side of a central boundary. In short, the two halves of a work mirror each other. So that's the meaning of symmetry. One side is a mirror of the other side, or on its right side. So that's how we define a symmetry. Shapes and patterns are very identical, that when you try to have it or divide it equally, the two division of things are like a mirror, or they look like a mirror of each other rather, sorry. Okay, so that is symmetry. Another thing is asymmetry. Another form of balance is asymmetry, is an arrangement of parts in which the opposite sides divided by a central line are not identical. So they are not identical. So unlike in symmetry, they are the patterns or the shapes that are divided equally are identical, but in symmetry, they are not. They are not identical. Next is the radial symmetry. This is very new to you, I guess. It is a form of symmetrical balance in which the elements of a composition radiates from a central point in a regular repeating pattern. So this radial symmetry can be found in nature, like in flowers, starfish, jellyfish, crystals, and snowflakes. So they have radial symmetry. Another term that we need to be familiarized of is the word proportion. So in art, a proportion is the principle of design concerned with the size of relationships. Again, size of relationship of parts of a composition to each other and to the whole. So in math, we say proportion, it is division, it is ratio related to one part or another to the whole with respect to the size, quantity, and degree. That's how we define proportion. Same in arts. But in arts, it's just like an application of what we have in the concept of mathematics of proportion, which can be defined as, which is defined rather in arts as um, principle of design concerned with the size of relationship of parts of a composition to each other and to the whole part. Okay? So I hope you can follow, and please do not forget to remember the terms in here because these are very important in this chapter. So now let's proceed to perspective. Perspective in geometry, or in this geometrical concept, it is defined as a system of representing three-dimensional objects. So I will just highlight this one so that you have a clue term in order for you to remember the definition or concept of perspective. Again, it is a system for representing three-dimensional objects viewed in a spatial recession on a two-dimensional surface. The simplest form of perspective drawing is or can be found in a linear perspective. It is a system that allows artists to trick the eye into seeing depth on a flat surface. So in short, a perspective is a system used to represent the three-dimensional object which is viewed in spatial recession on a two-dimensional surface. So I just want you to remember this definition of a perspective. So now let's proceed. How to analyze geometric shapes according to the level of geometric thinking. Analyzing geometric shapes according to Vojkovkova 2012 can be done using the Van Heldt theory of geometric thinking. And according to Pierre Van Heldt, there are 5 levels of thinking or understanding in geometry that I want you to remember. How to analyze geometric shapes according to the level of geometric thinking. Again, we have how many levels? 5 levels. So let's start with the first level, the level 0. This is known as visualization, or the level of visualization, or the basic visualization or recognition. So at this level, the pupils use visual perception and non-verbal thinking. So please take down note of that. At this level in visualization, we use visual perception and non-verbal thinking. They recognize geometric figures by their shape as a whole and compare the figures with their prototypes or everyday things. Categorize them, and they use simple language. They do not identify the properties of geometric figures. The pupils describe figures on the basis of their appearance, based on what they see. They describe the figure. That's according to level of visualization. What they see will be what they identify or describe. Okay, so example, squares and rectangles seem to be different. So using your visualization or the basic visualization or recognition, we can say that squares and triangles are different, correct? So that is level 0. So next, let's proceed to the next. Next level, we have level 1. This is now analysis, making description. A while ago, we just tried to see or using our uh, visual domain to describe a certain thing or certain figures. So in this case or level, the level 1 is the analysis part. At this level, pupils or students start analyzing and naming the properties of geometric figures. So example, a while ago, we based on what we see or our visual, we see that triangles and rectangles and squares are different based on how we see it or based on its appearance. Okay, so in this level 1 level 1 in the analysis level, the students will be able to analyze and try to name the properties of the geometric figures. So example, rectangles have 4 right angles. So we in this level again, we analyze and we identify the properties of the geometric figures. And level 2, we have the abstraction. In this level, it is an informal deduction or ordering or relational. At this level, pupils or students perceive the relationship or relationships rather between properties and figures. So they create meaningful definitions. So they're able to give simple arguments to justify their reasoning. Example, simple deduction can be followed, but proof is not understood. Okay? Again, in this case, they can already, aside from visualizing, aside from analyzing, they can make abstraction. They can create meaningful definition. They can even justify their reasoning. So why is it rectangles have four right angles? Based on the illustration like that, they can explain things or they can explain their reasons or justify their reasons. So this is where the level 2 is trying to, or yeah, this is how we describe the level 2, which is the abstraction level. Okay, I hope you can follow. And in level 3, we have here the deduction or the formal deduction. At this level, students can give deductive geometric proofs. They can already, in level 2, the difference in level 3 from level 2, in level 2, they can only just justify their reasons. They can argue. They can create meaningful definitions. They can even perceive the relationship between properties and the figures. But in level 3, they can already give deductive geometric proofs. It is like giving a formal reasoning to justify their arguments. So that's how the deduction level, that is how the students in this deduction level perform. They can give deductive geometric proofs. They're able to differentiate between necessary and sufficient conditions. They identify which properties are implied by the others. They understood the role of definitions, theorems, axioms, and proofs. Examples. Proofs can be written with understanding. They can already write a proof because they can already justify and analyze and even to make an abstraction of what they have perceived or learned or figures that they have perceived or have seen rather. So this is where the level 3, or we can describe the level 3 or the deduction level. So I hope you are still there and you can follow. And last, the level 4, the rigor. At this level, the students understand the way mathematical systems are established. They're able to use all types of proofs. They comprehend Euclidean and non-Euclidean geometry. They're able to describe the effect of adding or removing an axiom. So in short, at this level, they can already establish their concepts of geometry. They can now identify the difference between a non-Euclidean and Euclidean geometry. So based on the example, non-Euclidean geometry can be understood. So they can already explore the concepts that they have learned and have seen. So from level 0 in here, from level in level 4, they can already interpret what they have learned. They can already justify, they can already make proofs, and they can even understand and explore more about the concepts of geometry. So I hope you can comprehend or you can grasp the concept that I am trying to imply in this level. So now, talking about the properties of the levels, it is inherent in the Van Hale theory that one considers the following properties. First, fixed sequence or order. The student cannot be at level N without having gone through the level N to 1. So in short, it's a process. It must undergo the first step until the last step. It will never jump to other step. Example, level 1, 2, Next is level 3. No, it must pass through level 2 before going to level 3. So that is what it implies there in number 1, the fixed sequence. A student cannot be at level n without having gone through the level n to 1. So therefore, the student must go through the levels in order. So I will highlight the word in order. So next is adjacency. So after in fixed sequence, we will now talk about agency, which are part of the properties of the levels. So at each level, what was intrinsic in the preceding level becomes an extrinsic in the current level. So I hope you can follow. Distinction. Each level has its own linguistic symbols, and it has also its own network of relationship connecting those symbols. The meaning of a linguistic symbol is more than its explicit definition. So what may be correct at one level is not necessarily correct at another level. And that is what we call distinction. They have their own identity in each level. So next, separation. Two persons at different levels cannot understand each other. The teacher speaks at a different language from the student who is at a lower level. So the Van Hale thought says that this property was one of the main reasons for failure in geometry, the separation, because they could not understand what their teachers are trying to say, since they don't have developed yet the concept or the basic concepts of figures or basic concepts of geometry. Next is attainment. The learning process leading to complete understanding at the next level has 5 phases. We have the information, guided orientation, explanation, free orientation, integration, which are approximately not strictly sequential. So in attainment, it is attaining or perceiving or gaining the concepts of geometry. Okay? While passing through the levels that Van Hale theory uh, is introducing to us. Okay? Has introduced to us rather. So now transformation, let's talk about something related also to what we have learned there in properties of the levels, which may also help us develop our concept in geometry. So in geometry, we have to know more about the definitions of transformation because figures are transforming. Same with numbers, same with occurrence of a certain thing or event or phenomena. So according to Jennifer Bedo, 2003, in geometry, transformation refers to the movement of objects in the coordinate plane. So the concept in here is the objects or the figures are moving. So transformation is being defined as or refers to the movement of objects in the coordinate plane. So this is how we define a transformation in geometry. Definition of a transformations in this context of mathematics in the modern world. Geometric transformations involve taking a preimage and transforming it in some way to produce an image. There are two different categories of transformations. I want you to remember that one. The rigid transformation, which does not change the shape or size of the preimage. The second one, the non-rigid transformation, which will change the size but not the shape of the preimage. So one thing that we need to remember, an easy way to remember this one, when we say rigid transformation, the shape or the size does not change when they move or when they transform. When they transformed, rather, non-rigid transformation, there will be a change of size but not the shape when they transform or when the objects or figures move. Okay, so take down note. Change in the size only for non-rigid transformation. For rigid transformation, it does not change the size nor the shape. So now let's proceed to the types of transformation. We have this, what we call rotation. So there are 4 types of transformation. As you can see, we have or three of them fall in the rigid transformation category, and one is a non-rigid transformation. Okay, so let's start with the rotation. Rotation is a rotating an object about a fixed point without changing its size or shape. As you can see, this is how it is being illustrated in here. The turn in the rotation, from here it turns into this, but it never changes its rather sorry, it never change its size or shape. It's still triangle, same shape when it transformed or moved in the Cartesian plane. Another thing also is the translation. When we say translation, it is a moving an object in space without changing its size, shape, or orientation. So this is just the same as that a while ago, the one that we talked about a while ago, the rotation. Translation is it will not change its size, shape, or orientation. A translation is performed moving the image to the requested number of spaces. So the movement is different. It's like sliding, and it's not like turning, because when it turns, it is rotation. But when it slides, it is translation. So this is the difference between the two. See the difference? It's sliding from here over here. It slides going up there. So it's three-dimensional perhaps. So, but the size and shape or orientation didn't change. Next is dilation. Dilation is expanding or contracting an object without changing its shape or orientation. This is called resizing, contraction, compression, enlargement, or even expansion. The shape becomes bigger or smaller. So this is dilation. The shape becomes bigger or smaller. As you can see from here, from this point, so it's getting little bigger, or yeah, bigger in its size. Okay, so that's how we define a dilation and illustrate it. We illustrate dilation in that way. Okay, now let's proceed to the next, the number 4, the last one. We have this what we call reflection. Reflection is a flipping an object across a line without changing its size or shape. So number 3 is part of the non-rigor transformation, because it changes its shape, correct? So reflection is flipping an object across a line without changing its size or shape. So as you can see there, this is how reflection being. It's still flipping. So I hope you can identify the difference between a rotation and a reflection. So it's still what I mean. You can differentiate, yeah, the difference between rotation and reflection. Rotation, it's like turning, it turns, but in reflection it flips. So I hope you can follow. So next, let's proceed. There is a psychology of shapes that we need to know about, and according to Siddhant Pillai in 2018, the most common shapes are the angles, triangles rather, circles, um, rhombuses, and hexagons. They can be broken down something like the following, as you can see. So we have again common shapes that can be broken down, like the rectangles, as you can see. There is a balance and tradition. So this one, the shape, the circles, the triangles, there is stability, energy, and aggression. For rhombus, there is a vibrant and contemporary. For hexagon, there is a unity and balance. So this psychology of shapes presents the shapes and their meaning. So the perceived meanings that rectangles or squares exude are balance and tradition, as you can see. Rectangle or squares, again, they can be, are their meaning, they perceived, or the perceived meanings of the rectangles or squares, they are balance and tradition. For circles, there is infinity, protection, and femininity for circles. For triangles, the meaning, I want you to remember this one, the psychology of shapes. There are meanings of the shapes that we have here, that we perceived in here. For triangles, there is a meaning in psychology that means stability, energy, and aggression. For rhombus, the meaning of rhombus is in psychology, vibrant and contemporary. And for hexagon, there is a unity and balance. And of course, rectangle and or square, they have balance, and there is a balance and tradition. So amazing, right? Triangles are for stability and energy and aggression. Rhombus are for vibrant and contemporary. And hexagon is for unity and balance, as I have said a while ago. So these are the psychology of shapes. So I hope you will be able to communicate with the psychology of shapes. You'll be able to know what's the meaning of the shapes that we have there. Okay, let's proceed to another slide. Yes. So in this section, we are going to define what is geometric patterns. We have talked about patterns, geometric concepts, and now we will try to connect them as one. When we say geometric patterns, it is, or we can define it as a collection of shapes repeating or altered to create a cohesive design. A repetition or collection of shapes and figures that can create a design, artistic design. So that is geometric patterns. So how to use geometric patterns in designs? There are 40, but I will just introduce 25. At least you will be given only the idea about how to use geometric patterns in designs. First is use patterns to create images. Yes, patterns can be used to create images. Okay? So again, how to use geometric patterns in design? Use patterns to create images. Second, play with asymmetry. Third, you can combine patterns with photos. Correct? That's how people are doing, especially photographers. Use lighting and shadows creatively. Connect shapes in unique ways. Make a collage. Okay, that's how to use geometric patterns in designs. So you can choose any of these. Okay, I am just presenting you 25 common use geometric patterns in designs that can be used rather, or how to use rather geometric patterns in designs. So now let's proceed. Use diagonals. You can use diagonals. You can create isometric patterns. You can create patterns with font. You can play with symmetry. You can use patterns within patterns. You can keep it simple, of course. Think about different ways to use lines and create a theme. You can also use gradients or the slope, number 15. And for 16, you can create characters. You can even combine several different images. You can emulate an effect with shapes. You can create a background. You can create overlapping shapes. You can even relate patterns to the subject. You can use patterns in the letters. You can use a pattern to alter images. And you can choose colors that work together. And you can use that enhance the experience. So these are the things that we can help us, or how to use geometric patterns in designs, patterns in designs. Okay, so we will end our discussion about geometric patterns uh, in number 25, or in this slide rather. So I hope you are learning so far about geometric patterns, and next time in our video discussion, we will talk more about computing. We will compute. In this case, we will not compute. We are just describing about some concepts related to geometry. So now we will call it a day. Thank you for listening, and I hope you have learned something. Always remember that the essence of mathematics is not to make simple things complicated, but to make complicated things simple. And always remember, math is fun because math is art. Thank you and have a good day. Thank you for listening.